Okay, hello. Now we're going to look at the QuNeo control surface. We have a couple of these and they're made by Keith McMillan. They look like this. Every one of these buttons is a three-dimensional control source, so it gives you X, Y and pressure. And then you can pinch using this bottom scale, and you have various faders and other controllers here. So the first thing in order to do this that we need to do is to open a little app called QuNeo OSC Bridge and set up here the address that we're sending to, the internal address here, 127.0.0.1, that'll come up there, and the output port, the port that we're sending to, right? And you don't need to worry about this part at this point. And then I've made a little patch that is up on the website. And in here, you can see some things that have become familiar to you, which is UDP receive, and the port 8020 is the same as the send port down here. And then I'm using a message box here just to see what's coming in here. So if I move some things, you should see some information there. And you can see that this is first of all coming from the QuNeo, that's a vertical slider, 0. There's information there about note velocity, which is the pressure I'm pushing onto that slider, because everything is pressure sensitive. And so if we just do some quick experiments here, we find that there are a bunch of drum pads, so QuNeo/pads, a bunch of sliders, a bunch of other things as well, but these are the only ones we want. So first of all, we divide out everything that comes from the QuNeo here, because we could be using WiiMote, we could be using Wacom tablet as well, and here we would just add in here other things. So let's say messages that we were sending from a Wacom tablet would now come out of the second output, and the WiiMote, or just let's go Wii, would now come out of the third outlet. Okay, so this is a way of dividing up multiple controllers here into different data streams. So we get the QuNeo, here comes out the first outlet. Then we've just looked here and seen that we have two different types of controllers that we're looking at. There are more, as I say, but I'm only looking at two here. Pads, the drum pads, the vertical sliders. So we separate those out. Now I just want to define a couple of those, two pads, the pads 4 and 5. Remember that everything here starts at 0. So pad 4 is the first on the pad on the left on the second row of pads, and 5 is the next one. You'll see here that there are additional pieces of information, which are that it's pad 4 in this mode drum pad. I'm looking for the pressure, I'm looking for the X coordinate and the Y coordinate, and I'm doing the same for 5. And then you'll see for the vertical sliders that come out of the next output, that the slider 0, location 1, location 2, location 3, location. So I'm looking for the location or the setting on those sliders 0, 1, 2, 3, 4. So if I move the third slider, you'll see data here coming out, 127 at the top, 0 at the bottom, sending out full range of MIDI. If I move the first fader, you'll see that go up and down there. And you'll see the first fader is called 0, not 1. Okay. Now, if I push on pad number 4, you'll see pressure data, but you'll also see as I push across the pad left to right that the X coordinate here is now 0. As I move across to the other side, up to 127, back to 0, and you'll see the Y coordinate stays, much the same because I'm not moving around the Y. But if I push up at the top of the button, I can make that Y coordinate go up or down to 0. So I've got X, Y, and pressure here, which is, well, a lot of control off a single button. And then you'll see here I've put in outlets. These are called outlets. You can see them here, which allow us to send these messages out of this sub patch. Okay, and they look like that. I'm going to delete that one because it'll show up as an output. Alright, so I'm going to close that, and that's all contained in what's called a subpatcher, P or subpatcher, or patcher, there, okay? And that allows you to make another patch that's inside there. So in this case, we have a subpatch in here, which I've called OS Scaler QuNeo. Here it is. And then you'll see that on the output here, we have all of those outputs that we've put in. Let's just open this. So we have here 10 of these, and we can go along here and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so we know what's coming out of each of those by looking here. So you can see I've used the first one here, which is going to be the drum pressure, the pressure on pad 4. I brought that out here. Then I miss the next two and go to that, the fourth one, miss these two, go to here, just the pressure on pad 5. Miss another couple, which is X, Y, and go to this one, which is the first of the sliders, slider 1 here. Okay. Now we could also duplicate that, Apple D, and decide that we want the second slider here as well, and that would be that connected now, which is the second slider. Okay, so we'll just close that. Now, if this is sitting here so that you can see how to make a MIDI note and send it out, we'll get around to that later. Now then, if we look, these numbers are coming out here, 1, fader 1, fader 2, and then you can see that they're going into control out, which is generating a MIDI controller number, continuous controller, which is being sent across the MIDI network now. So we're turning open sound control data that's coming in using this into MIDI. Now you might say, why would we bother doing that? And it's absolutely true, we don't need to, because the QuNeo is also a MIDI controller. So we could just be getting this information from a single MIDI input and not worrying about this max patch. However, if you decide that you want to do a network performance with several computers in your ensemble, by turning the data into open sound control, you could now send this data from here to another computer or to several other computers. And therefore you could share this MIDI controller connected to this computer on several other computers and several other setups, which would mean that you could each have different channels, let's say in live, that you were all controlling from different laptops and different locations in the room or whatever you wanted to do. Now let's just have a look at this control out. If we open the patch, hold down the Option key and click on that object, it opens the help file. And it tells us here that the object takes a couple of arguments, and those arguments are the port number, the device number, and the controller number. So this can be a little bit confusing, and particularly because they don't actually go around in this order. But if you look at these objects that I have here, they're all got a 6 in them. And that actually is the port number, or the MIDI port that the data is being sent out of. And there are 16 ports on each MIDI channel. And so this is the one that it's using, 6 in this case. The first number is the controller number. And again, there are actually 127 of those. And in this case, I'm using 1, 3, 2, and you can see this one I just put in is also on 2, so that won't work because they must be different. So I'm going to make that 4, and now that will come through as continuous controller number 4 on MIDI channel 6. There's a bit more information here about ports, and it may be useful to use either a letter or to use a menu using MIDI info to be able to quickly select which device you're sending to. Now let me just show you that. I'm going to lock my patch again. If I double click on this controller object, I can see all of the MIDI ports that are on my computer at the moment. I've got the QuNeo plugged in, the QuNeo OSC bridges plugged in, there's all kinds of other things there, as you can see. Now, in your computers, the IAC, which is the inter-application communication bus, should be turned on, and you need to select IAC driver bus 1. That probably says, it could say other things. You need to click on all of these and select them. Now, if you own Macs on your own machine, a quick way to set this up is to go up to, I have to remember where it is, MIDI setup, and look in here, and you'll see output IAC bus, and it's got a letter in here. We can change that letter, but in this case it's I. Now, if I came into these control out objects, and before the 1 I put an I, then in fact every time I open this patch it will automatically find the bus that's set up here with that letter I, okay, which is the IAC bus. If I want to send it to from Macs, I have that set up as A, and if I change this letter here, well, let's do it on this one, I put in the letter A here, it would look for the device which is associated with the letter A, which will be from Macs. You can see it's automatically done that. But I want in this case to use the IAC bus, so I'm going to put I there. Now these letters won't be set up on your computers, but you could do that by going in Macs to the MIDI setup and making those letters, and then it should open consistently and find those ports for you, and that means you don't have to double click on them, and make sure that you select them like that. Okay. Alright, so now what we have is any data that we're getting from our QuNeo, the pressure of the pads, 1, 2, faders 1, fader 2, is being sent out on the IAC bus and should be available to any other application on the computer that uses MIDI. Okay, so we've now turned this open sound control data into MIDI to send internally, but we also have open sound control data that we can send now to any other computer. So let's go to live. Here in live, I've got a little ethnic patch going on, and I've recorded some crazy MIDI notes in here, and so that's basically all ready to go. If I hit play, and you'll hear that playing. And now what I want to do is I want to actually map a couple of things to MIDI controllers in live. So how do we do that in live? We go up here to MIDI, click on that, and you'll see everything that's possible to map turns blue. Now you'll see here that actually I've already mapped a couple of things, and you can see those in this list up here. I'm going to delete those, just select them and delete them so we can do them again. So I want to control the intensity of the cutoff on this filter here, and so I'm going to click on that, and you can see it's now selected, and I'm going to move my first fader. And you can see here that channel 6 controller number 2 has been selected, and if I now turn off MIDI mapping by clicking back up here and move my fader, you should see that knob turning when I move the fader on the control surface. Okay, so now if we play back the audio I've got recorded, and we'll bring that intensity up. You can hear it's brighter at the top. I can pull the top end out and make it duller with that fader. Okay, so now I'm going to go in and map another controller, clicking MIDI. I'm going to go down here to this mass. It's a spring physical model, and there's a certain amount of mass in the thing that's sent to hit it. I click it. I'm going to control that with one of the other buttons, in fact. Turn off MIDI. Now I can push that button and we should see that change. So let's play this back. I'll change that control. Bring up the intensity a bit more. Now you can hear a bit of a kind of rattling of that mass hitting the string. Increase the mass. Get it cleaner sound. And so on. So you can see that we can get real-time control over these two things. Okay, now one more thing. You could probably hear that using the mass was interesting between somewhere like here and here, but not over the whole range. So if we just click on that and we go back and open MIDI mapping again, we'll see that it comes up here. Here we go. Now, if we, let's just make this window a little bigger. Okay. Now here you can see the minimum and maximum percentage of those elements of the controller. Let's just pull these back so we can see these names a bit more easily. Okay. And what I would suggest is that this is probably more interesting between about 15% and then at a maximum of, let's say, 60%. And now I've rescaled that data so that when the pressure is off the button, the minimum is 15, the maximum is 60. So let's just go back here and push that button, and we can see if we watch this spring mass carefully, the fling mass, that this is not going below 15 when I let the button go, and it's not going above 60. So let's try that. We'll better give it some intensity again. So keep an eye on this mass. And you can see that now we have a more controlled range of flexibility on that spring mass. So that's using those MIDI continuous controllers mapped into Ableton, and to do that we've had open sound control input from the QuNeo, and then we've used Max to take the open sound control data, which is what we would get, say, from the WiiMote, and to turn that into MIDI continuous controllers. We've talked about mapping to port numbers here, IAC, internal bus, and how in Max we could use MIDI setup to set letters for those output buses. I've set I for IAC, which allows me then to put an I in here, and these automatically select that as my output bus. Saves me having to go through all my MIDI outputs to find out which bus they're connected to. Now, just before we finish, here is the help patch for Make Note. So if you want to take a particular control, a button for instance, whether the button is on or off, and turn it into a MIDI note number to control something, then in this case we would make a note, and this is the note velocity and duration, and then we would send a number in here. So if we sent, let's just make a message and make a note number 76 and send that in here. Now we need to connect the note out to a relevant thing, and it's connected to the internal synth, so we should hear this, and let's just send that number. We did indeed hear that. Now, it lasts for 1 second, which is 1,000 milliseconds at a velocity of 60. Let's turn that up to 120, which is almost fully turned up. It's in a range of 0 to 127. And now it's louder. So we could send any note number we like in there. If I just scroll up through notes, we'll get lots of them, etc. And if we have a bang here, set that up to there, and we say, well, when I pull my switch, this is true, 1, then we can say, well, let's select when the output of the switch, the button on the WiiMote, for instance, is 1. And when that's 1, we will send MIDI note number 79. And that will basically act exactly as that pitch is. So here you're making a note with a velocity and a duration, sending that out to make note, sending make note to an appropriate place, if we put it on the IAC bus and go back to Abelton and come in here and make this record ready, we should be able to play that physical model that we have in here. So you can see we're sending a MIDI note number out of Max to Ableton Live. Yep. And so this is how you would make MIDI note numbers.